Okay, we're moving on to our third unit. We're going to be dealing with real numbers, also known as rational numbers and irrational. You're going to be able to identify rational and irrational numbers today. That's your main learning target today. You're going to tell me if a number is rational or irrational. A number is classified into different subsets. So what we write subsets in front. I forgot to write that in there. So subsets of real numbers. You're either a whole number, you're a natural number, you're an integer, or you are irrational. So include that too. Okay, whole numbers. Whole numbers is how you count 1, 2, 3, 4, 5, 6, 7, 8 with 0. I think whole means it looks like a 0, it looks like a whole. So you can include that. So whole numbers are 0, 1, 2, 3, 4, all the way to positive infinity. Write that down. You'll want to remember. This is one of my main learning targets too. Natural. Think, how do you naturally count? So everyone count to 10 for me. There you go. 1, 2, 3, 4, all the way to positive infinity. What is the difference between natural and whole? Nothing. Zero. The whole looks like a 0. So natural, think how I'm naturally going to count. Whole numbers has something that looks like a whole, which the only number that looks like a whole is 0. Integers. The technical definition of integers is whole numbers and their opposites. Okay, so whole numbers are 0, 1, 2, 3 to positive infinity. And their opposites, negative 1, negative 2, negative infinity. So that's integers. Integers, the technical definition is whole numbers and their opposites. Are there decimals in any of these? Do I have like a 1.1? No. Negative 1? No. All of these, whole numbers, natural integers, are no decimal. So maybe I want you to write that. No decimal. Okay. So part of your learning target with this unit is being able to identify subsets of real numbers. That means I'm going to give you a number and you tell me where it falls. Is it whole? Is it natural? Is it an integer? Or irrational number? We're going to deal with irrational definition later, so I'm not going to put that there. First, we're going to define rational numbers. In 7th grade, you learned rational numbers to be any fraction. That's what a rational number is. You can write it and identify it as a perfect square root. I forgot to put root there. Not as important. It's a perfect square root or a fraction. Technical definition is it's a ratio A to B such that A and B are integers and B does not equal 0, meaning fraction. Okay, ratio is a fraction, and you can't have decimals as a fraction. That's what that means. So technical definition is a ratio of A to B such that A and B are integers, right here, no decimals, and B can't equal 0, because you can't have 0 on the denominator, ever. So that's rational numbers. Irrational is very easy to recognize. There's only a few things. It's not a perfect square root. I forgot the root again. It's a decimal that doesn't repeat or have a pattern. Now what I always ask myself when I'm dealing with is this a rational or irrational? In my head I always say, can I turn it into a fraction? Can you turn 0.5 to a fraction? Yeah, this is 1/2, so it's rational. So the easy way to think about it is, can you turn it into a fraction? If you can turn it into a fraction, it's it's rational. What about 0.8 repeating? Can you turn it into a fraction? You learned it last year. Let me see it. Does anyone remember what that fraction would be? It's not 8/10. That's the most common answer. It's not. Because it's not 0.8. Linz?
Is it over 9?
Yes, Lindsay. It's 8/9. Okay? So any repeating ends with a 9. So if it's 0.7 repeating, it would be 7/9. If it's 0.76 repeating, two numbers are repeating. It would be 76/99. That's how you do that. So, okay, a square root. The definition of a square root is a number when multiplied by itself gives the number inside. And now we're going to start applying these vocabulary words. So what is the square root of 4?
2.
2. What number times itself is 4? 2. I want to pause for a second, and I want you to take out the calculator you're going to use today. All right. So the square root of 25, I say what number times itself is 25, and I know it's 5. Square root of 121, what number times itself is 121? And I know it's 11. All right, so before we do this page, I want to go to
This page.
this page. The web, the rational web.
I don't want.
So you go to that rational web page, because in order to identify rational and irrational numbers, we need to be able to look. Some of us won't have to look, but some of us will want that reference. So a rational number, remember, is a ratio of A to B, such that A and B are integers, also known as fraction. Okay? So a rational number is any fraction. Any fraction is rational. So if I give you a number, 4/9, and I say, hey, is this rational or irrational? You say, it's a fraction, so it's rational. You want to know what else is a rational number? A perfect square root. You want to know why it's rational? The square root of 49 equals 7, which I can turn as a fraction 7/1. That's why a perfect square root is a rational number. A number that has a pattern. So a repeating decimal. Like 0.4 repeating. That would be rational because I can turn it to a fraction. It is 4/9. And another rational number is any kind of terminating decimal. Okay, a decimal that ends, like 0.12. It's not a pattern, but I can still turn it to a fraction, 12/100, can I? Number over place value, 1000. Which of course you'd simplify, but I'm not going to deal with that right now. Actually I am, because it's bugging me if I don't. 6/50ths, which is what, 3/25? Okay, so a rational number is anything you can turn into a fraction. Let me give you an irrational web. So make another web. This one is much smaller and easier to use because it's smaller. You want to know what? Two things. Irrational is pi, because it's a never-ending decimal, and there's no pattern to pi. So you can't turn it into a fraction. And another irrational is the square root of not a perfect square. And that's pretty much what you're going to be dealing with today. It's going to say something like the square root of 17. Is that rational or irrational?
E.
And you would say, well, is this a perfect square? No. This is not a perfect square, so this would be irrational. Okay, now that we know what rational and irrational is, let's go back and apply it right here. Identifying rational and irrational. So you might want your web today to help you decide what's rational and irrational. You're going to find that what I'm typically going to say aloud in my brain when I think, can I make it a fraction or is it a perfect square root? Those are the two things I tend to ask myself. If it's not a perfect square inside the square root, it is irrational. Remember that. All right, let's classify. The square root of 100, is that a perfect square?
Yes.
100 is a perfect square, which is 10, which I can make as 10 over 1. So that is a rational number. What about 3/4? What's a fraction? Is a fraction rational or irrational? Rational. That's a definition of a rational number. Can you make it into a fraction? Yes, because it already is. What about 0.36 repeating?
But it doesn't have to repeat.
Oh, well, it's to be expected. Like your calculator doesn't have repeating signs either. You're just supposed to expect it. But the 6 does repeat, so this is a pattern. We can turn that into a fraction. All right, and then I have negative 1.234. So it's a repeating, which means I can turn it to a fraction, which means rational. The square root of 37, is that a perfect square? But it's not a perfect square. Irrational, because it's not a perfect square. Negative 5/13, is it a fraction?
Yeah.
It's a fraction, it's rational. Okay, but now I'm going to look hypocritical. This is a fraction, right?
Yes, but it has a square.
But it has a square root. And the definition of a rational number is a fraction such that a and b are integers. Square root of 12 is some kind of decimal. It's not a perfect square. So it would be, whoopsies, it would be, oh man, I really messed that one up. It would be irrational. Okay? Yeah, it would be a really weird number. Okay, last learning target of the day for part A of 1.3 is dealing with fraction square roots. I love fraction square roots because they look super fancy, but they're kind of easy to do. All you have to do, see how fancy they look?
Yes.
All you have to do is take the square root of the top, take the square root of the bottom, and then simplify.
I got it.
So, for example, and we didn't do this in 7th grade. This is not a 7th grade standard. So what we do is distribute. Do you see how the square root is around everything? We can distribute the square root. I can turn this into the square root of 9 over the square root of 36. Okay, do you see what I did? I took the big square root and I shared it to the top and bottom. I distributed. What's the square root of 9? 3. What's the square root of 6?
30.
Or, just kidding, 36. What's the square root of 36?
Or you get half.
And then simplify. So notice my strategy. Square root at the top, square root at the bottom, simplify. Okay? The square root of 16/9. I'm going to take the square root of the top, the square root of 16, over the square root of the bottom, and then evaluate. Root 16 is 4. The square root of 9 is 3. 8th graders, leave it in practice.